Okay, guys, welcome back to another lesson. Okay, graphing linear absolute value inequalities. This might look familiar from Algebra 1. If it is, great. We're going to combine some of the stuff we talked about with absolute value in this lesson, hence the title. It might behoove you to have graphing paper. Okay, we're going to do a lot of graphing today. I'm also going to upload a smaller video after this that has additional examples with these problems, okay? But we are going to use some transformation stuff, which will help with the graphing of this, okay? So taking a look, we described transformations on functions. That was our very last lesson. Today we're going to graph linear and absolute value inequalities. So linear inequality and boundary lines we're going to be talking about in this lesson, okay? So just kind of getting a feel for this first. Remember, an inequality has more than one answer, right? So if we're looking at graphing this, we're not looking at answers that are directly on the line. Sometimes we are. But we're looking at answers that are above or below that line, okay? And what solutions can satisfy this guy. So take a look at the first one here. X minus 2y less than 4. Now, what I would highly recommend, now we could actually plot zeros in, and then based on the intercepts, draw your line, but I think it's easier to put this in slope-intercept form. So I'll take x to the other side, so negative 2y less than 4 minus x, and then divide both sides by negative 2. Got to be careful because it's going to flip the sign. So we get negative 2 plus a half x. Okay. Now, for our next step, well, for my next trick, we're going to go ahead and graph this. So, I probably should have had this done ahead of time. That was poor planning on my part, wasn't it? There we go. All right, so now let's graph this. So ignore the inequality symbol just for right now. The slope and the y-intercept. So we start at negative 2, so we're right down here. The slope is going to be up 1 over 2. So we just need 2 points. So I'm going to go ahead and draw my line next. Now here's where you have to be careful, all right? If there is no equal to sign, we have a dotted line, okay? Now notice, can my y values equal what's over here? No. So I'm going to do a dotted line, just like that, okay? That dotted line indicates that any numbers on this line doesn't work for that, okay? Now shading. Let's get some colors. Let's make this pretty. Let's, I don't know, red, green. I have this nice blue that just doesn't work. Goodbye. So let's take a look. We want y values that are greater than this guy. So when you think about greater, would negative y values down here be bigger than that function? No. So it's going to be above this function and all this up here. So you can go ahead and shade like crazy. Okay, anything above this line. Now, how do I know that this region has all my answers that'll make this work? Test the point out, okay? See how the origin is part of this? Let's do it. So let's test the origin point and see if that works. Okay, so test the point. So let's see, 0 is greater than negative 2 plus a half times 0. Okay, 0 greater than negative 2. Yep, that works. You could pick another point out here. Okay, we could pick this guy, which is 1, 2, 3, 4, 5. That's 0, 5. 0's here, right? Negative 2's here. If I put 5 in there, that's 2.5. Add negative 2, that's negative 0.5. That's definitely less than 0. So you have ways to see if this works. Any questions? It should look familiar. Really should. Okay? But that's what I would do first, is put this in slope-intercept form, which is this guy right down there. Okay, graph it. Is it solid or dotted? Okay, so it's dotted if there's no equal to. Solid, otherwise. I'll put there. Otherwise, indicating that you're allowed to use those numbers on the line. Okay? And just for you guys, ta-da, we match. Okay? All right, let's try another one here. So let me just erase this. Okay. Which graph is the graph of this guy? All right. So if I'm looking at this, I'm probably going to put this in slope-intercept form first. So that's what I'm going to do. So I'm going to write this over here, and I encourage you to do so in your notes. Take 2x to the other side, so 5x is greater than negative 2x plus 10. Notice I put the x's first to keep it in that mx plus b form. Okay. Divide both sides by 5. So y is greater than negative 2/5 x plus 2. Okay, let's think about this for a second. Y is bigger than this guy, right? So are we going to shade above or below the line? Above. Okay, so that's one thing we want to keep track of. So B's not a good one, and D's not a good one. So we're down to these two, right? These two graphs shade above. My slope's negative. Okay, well, they're both negative. Darn, I was hoping that would work. Is it solid or dotted? It's dotted. I'm not allowed to include those answers on the line, so it must be A. A is my answer for that guy. See how I kind of broke this down? Okay, just by what you see here on the graph, and the equation. And I was teaching a geometry lesson, so if you're wondering what that colorful cube is, that's what I was demonstrating with three-dimensional shapes. I've been teaching a lot of lessons today. All right, let's try another example here. So let me go ahead and erase this guy. Goodbye, so long. Get rid of this, get rid of this, get rid of that. There we go. Okay. One tutoring company advertises it specializes, I can't read, in helping students who have a combined SAT that's 900 or less. Now, I know a lot of ACT people are out there, so let me break that down. SAT, I think the highest score is 2,400. Okay, so if you only have 900 as a combined score, that's pretty low. So write an inequality to describe the combined scores of the students who are prospective tutoring clients. Let X represent the verbal score and Y the math score. Okay, so let me think about this. I have my math score plus my reading score, right? Verbal score. And if that value is less than or equal to 900, I qualify for this tutoring company, right? Does that make sense? Okay. So how's this going to look graphically? All right, well, let's figure this out. Looking at this, I'd put it in slope-intercept form first, right? So y less than or equal to, no, try that again, negative x plus 900, okay? So this is going to be a negative sloped line. It's also going to be a solid line, right? Am I going to shade above or below this line? I want y values less than. So I'm going to shade below the line. Okay? Makes sense so far? To preserve my wonderful grid, okay, I'm going to show you what this graph looks like on the PowerPoint. Okay? So here we go. So I'm going to go ahead. As you can see, my y-intercept's at 900, which is up here. It's negatively sloped, so it'll be in this direction. It's a solid line, and I'm shading below, right? Now you're probably thinking, okay, how does this translate into the problem? So glad you asked. Okay, taking a look at this, if I picked this spot here, that's 400, 200, right? So if I add those up, I get 600. Do I qualify for the services? Yes. Okay. How about this guy over here? This is what, 200, well, let's go up here. 200, 600. Okay, that's 800. When I add them up, do I qualify for the service? Yes. Okay. anything on the line is exactly 900, which still qualifies for the service as well. Does that make sense? So just in the sake of time, I'll just explain what the graph looks like here instead of me redrawing it over there. Okay? So let's do another one. Sorry. Pretty much that question was asking what I was doing. 2 social studies classes are going on a field trip. Teachers have asked for parent volunteers to go on the trip as chaperones. However, there's only enough seating for 60 people on the bus. Write an inequality to describe the number of students and chaperones that could be on the bus. Okay, so highly encourage you, pause the video to figure this out. So S is for students, C is for chaperone, and up to, 60 people? There's only enough room for 60, so it has to be less than that, right? And I'm allowed to have 60 on the bus, so it looks like it's this guy, right? So I think B is the correct option for that guy. Okay? So B would be correct. Now, graphing this. Okay, once again, and I'll tell you what, let me put this over here. It was students plus chaperone less than or equal to 60. Now, some people ask, Mr. McCullough, how do I know what's on the X and Y axis? Technically, it doesn't matter at this point, okay? You can pretty much, from both perspectives, say that this is independent, this is dependent, okay? So when I'm doing this, when you're not sure what to do, plug zeros in. So if I plug 0 in for this guy and this guy, what's the answer going to be? And make a decision. Students are going to be the x-axis, I'm going to say. Chaperones are going to be the y-axis. I could have flipped them, okay? I just made a decision ahead of time. Same thing with the SAT score. I know I led you to X and Y, but it doesn't matter. Okay, this was your math score, right? This was your verbal. If I would have flipped them, would the graph look different? No, it wouldn't. Okay, so that's what a lot of people always get confused about. It's okay. All right. The only time it has to be independent, dependent, specific is if, for instance, if time was involved. Time's always a good independent x-axis factor. Anything that is directly related to the other person. So in this case, it doesn't matter. So if I plug 0 in for this guy, the chaperones has to be 60. If I plug in 0 in for the chaperones, the students got to be 60, right? So right here, okay, is going to be my x-intercept, and this guy's my y-intercept. So take a look at my graph up here. See how I did that? This is my x-intercept, this is my y-intercept. All I need is 2 points to graph it. I can connect them. And then I'm shading below the line, right? Because I want values that are less than or equal to 60. So if I plug in, well, let's read the thing. Can 15 chaperones and 47 students ride the bus? The answer would be no. 15's right here. If I go up to what, 47? 47 would be roughly here. It's just outside the boundary. Okay, not by much, but just enough to where it isn't going to work out. Okay, it's going to be outside the shape. So do you see the difference now? So the first one was a standard, slope-intercept form. Okay, rearrange it, plot your graph, dotted or solid, and then shade. The application problems, you have to be a little bit careful, but I showed you 2 of them where you can plot just 2 points, or you can rearrange it and solve it this way. Okay, so 2 different ways of doing this. Let's continue. Okay, let's go into absolute value territory. So we have the absolute value. Y has to be greater than or equal to the absolute value of x minus 2. Okay? Going back to transformations really quick. This is telling me what? My normal absolute value graph is going to be shifted vertically, down 2? So we're going to go down 2. That's my transformation. So here it is. Okay? Other than that, everything goes the same. So here it is, my absolute value graph. Notice, It's a solid line because it has an equal to, right? So that's a solid line. Next, shading. Where do I shade this? I want y values that are bigger than that absolute value function. Would negative values be bigger than this function? No. So it has to be, I think what, inside this cone. Cone. You can tell it's the end of the day. My brain's just slowly, it'd be right here. Okay, be inside the absolute value. Okay, not on the outside. And how do we know? Check a point. So let's test a point out to make sure we did this correctly. So I'm going to pick, I'll make it easy, 0, 1. So is 1 greater than or equal to the absolute value of 0 minus 2? Well, when I simplify, is 1 greater than negative 2? Yes, it is. Okay? Just because. Why not? I'm not making the video too long yet. We got time. Let me test a point out here, just to prove a point here. Let's test what? Let's go up here. Let's make it even more interesting. Why is this not bigger than this? So 1, 2, 3, 4, 1, 2, 3. So 4, 3. Let's test that guy out. So is 3 greater than or equal to the absolute value of 4 minus 2? We're going to test another point just to prove that this is the correct shading. This shouldn't work because we went outside. 3 is greater than or equal to, was it 4 minus 2? Is 3 greater than or equal to 2? It is. Okay, so a lot of people ask, well, isn't this outside stuff? But no. Think of the function itself. I want y values that are bigger than that function. That's what this is telling me. Okay, so that's why we have to shade accordingly. And if you're not sure, test your points out. Okay. And on PowerPoint, I think I put this up there. No, I did not. Okay, ignore what I just said there. Moving on. Okay. Let's try another one. I thought I put that up there, but apparently not. So y less than the absolute value of x plus 3. Okay? And let me just erase this. We have options, don't we? If you look at the PowerPoint, I gave you options. Yes, I did. I gave you options. Okay. Told you I'm getting loopy. It's the end of the day. So first things first, what transformation's happening here? It's going to be shifted what? Up by 3. So it's going to be right here. Dotted line, right? Because it doesn't have an equal to. So any points that are on that function do not satisfy this. And I want y values less than. So that means I want y values down here, right? The negative ones. So this is what I'll do. I chose green this time. I thought we'd change it up. Green and red, we're getting to that time of year. I mean, if you're watching this at a different time in the future, then no, you're not. Okay. Once again, we can test a point out to see if this works. If I put 0, 0 in, is 0 less than, that's gone, 3. Answer would be what? Yes. Okay. So what option is this guy going to be? I think B, right? B is the correct answer. I don't know why C and D got shifted, but B would be the correct answer for that guy. Okay. All right. We do have time. I mean, yeah, we're doing it. We're going to do it. Let's add a couple more examples, okay? So the TV's gone. That was it. Goodbye. Let me just put this towards the center a little bit. Let me throw a couple more examples your way, because that one was pretty, those are basic, because we're just using some previous knowledge that we just talked about, okay? But now let's kick it up a notch. Let's try this guy. Let's say I had this. Okay. What would I do? Well, if you don't know what the graph looks like, plot XY points, right? But here's another trick that you can do. what number can I pull out of both 4 and 8? 2, right? And what I get, x minus 2? Something like that? Okay. Oh, wait. Wait. You should have been yelling at me, guys. Maybe you were. 4 can go out of both of them. Sorry. What was in my head didn't come out right. I could take 4 out. So far, so good? Okay, now, here's the other thing we can do. This looks like what we've done before. See how the 2 is inside the function here? And that means it's a horizontal shift, and we go opposite. So this is going to be a shift to the right by what? 2? Does that make sense? So I'm going to take my normal absolute value and move it over to the right by 2. Now that 4 is going to affect how far it's going to be going up, right? Rise-wise. Didn't mean to rhyme. So what would that look like? Well, let's plot some points. Just makes it a lot easier that way. So let's see. Let's just to make it more accurate. Let's plot -1, 0. I tell you what, we're going in the wrong direction. Let's do -1, 0, 1. You know what this is, so let's do 3 and 4, just to get the gist of what this graph looks like. I plug -1 into here, I get -3 times 4 is -12, gives me 12. 0 gives me -2 times 4 is -8, positive 8. 1, I get -1, gives me -4, becomes positive. 3 gives me another 4. 4 should give me another 8. Okay? And notice how this is kind of symmetric, right? If I were to go 5, my value is going to be 12. See how the values repeat? Which means right here is your, what? Starting point? Right there. Kind of cool, right? So, just with a little bit of symmetry. So taking a look, let's see, -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it's up here. 1, 2, 3, 4, 5, 6, 7, 8 would be like roughly here. 1 would give me 4, and then we just match it on the other side. Okay? It's going to be a solid, right? A nice solid line, because we're allowed to include those. What else could we talk about transformation-wise? See how this kind of went more, why can't I talk today? See how it got narrow? Because the value was inside, isn't that a horizontal dilation we're talking about? And it's going to be a horizontal compression, okay? So here's the deal. If you ever get a graph where you're like, man, there's no transformation I can pull. See if you can take a number out, and then you can start working on, oh, hey, wait a minute. There is some transformations that I can use, and see how quickly we graph that. Okay, so it's not that bad of a idea. Okay. Alrighty. So, should we do one more? Maybe. Gotta find my notes. Oh, here we go. Let's do one. Let's do another one. Oh, what the heck? We're gonna do 2. I like you guys too much. You guys get more. So here's another example. Okay, and unfortunately that goes to this graph. Goodbye, graph. See ya. There we go. Okay. So let's say this is my function, and now what I got to do, oh, did I not shade that last one? I didn't shade the last one. That was what, this guy, right? Real quick. It was what, less than, right? So I'd shade everyone underneath. I'm so sorry. I got got talking about transformations. I forgot all about the whole thing. It was about shading. We're supposed to shade. Okay. Get y by itself first. Add 1 to both sides. That's what I would do. Now looking at this is an absolute value graph. It has a couple of transformations. We're going to go to the right by what? 2, and we're going to go up 1, because that's what that means on the outside. So to the right 2, up 1. It's going to be a dotted, okay, because once again, not an equal to sign, so those values on the function won't work. I know y values are less than that, so that's going to be everything around it, okay, not inside of it, because this includes y values that are pretty big. There goes the lawnmower man. Okay, and if you're not sure, we can always test a pointer. So see how 0, 0 is part of that point? Let's just for fun, let's test 0, 0. So 0 less than the absolute value is 0 minus 2 plus 1. That's negative 2, which becomes positive 2, plus 1 gives me 3. So 0 less than 3? Yes. So we did this correctly. Okay? Let me give you one. This is the last one. I swear it is. Okay? One more to go. You're going to like this one. I could be wrong. I could be dead wrong if you won't like this one. But, what the heck. Oh, man. What is this one all about? Well, I got X's and Y's glued in there. Oh, that's a headache. How do I undo this? Well, absolute value has 2 cases. Once I break it up into its 2 cases, can I start rearranging them? I can. So let's do that. So let's break it up into its 2 cases. Remember that the second case, we change the sign and we change the number. The sign of the number. Go back to like our very first couple lessons. We explained why that happens. Okay, so for this guy, what I'm going to do is I'm going to solve for y. So negative 2y greater than negative x plus 6. Divide both sides by your negative 2's. So y is now less than, be a half x minus 3. So here's my first equation. Over here, I'm going to repeat the same process. I'll subtract x from both sides. Negative 2y is less than negative x minus 6. Divide both sides by negative 2, which means I got to change the sign. So I get a half x plus 3. I'll pause for a moment so you can look at that, write it down. Look what we just came up with. We had an absolute value graph that is now broken up into what? 2 lines. That's nuts. That's crazy. So we're not even done yet. We still got to, graph these guys, right? Okay, so let's do that. The first graph is at negative 3, then up 1 over 2. It's a dotted line because I can't include those values. Remember, I just need 2 points. And I'm going to shade below the line because it's less than y. So all of this stuff gets shaded. The other one has a y-intercept at 3, and then we're going to go up 1 over 2 again. Wait, so far so good? Did I miss a negative? I want to make sure I didn't. No, I didn't miss a negative. Okay. We're going to go ahead and make another dotted line. And then I'm going to shade values above it. Ah, that's a lovely marker sound. Isn't it? So, this is different, right? So I have solutions here and here that'll make this guy true. So because I'm stubborn, I hope you are in mathematics. I really do. Be stubborn in math. Don't just accept an answer and say, okay, that's it. Test it out. This is a weird situation, so I want to make sure this works. So we're going to test, what's this? 0, 1, 2, 3, 4. Let's test this guy. 0, 4. Let's see if that works. Okay. 0 minus 2 times 0, take the absolute value of that. Okay. See if it's bigger than 6. I'm sorry, this is 2 times 4. I didn't substitute that right. So the absolute value of negative 8, which becomes a positive 8, is that bigger than 6? It is. So this point that's in that shaded region works. I'm still not satisfied with this. I want to see if the bottom numbers work too. So let's try, we're going to test another point down here just to see. Let's do 0, negative 5. Isn't that down here in the shaded region? And I'm picking 0 because it's easy to calculate. You could pick any points outside of just the axis. I'm picking points that makes it easy to calculate. So let's see, that's 0 minus 2 times negative 5 greater than 6. Absolute value of negative 10 greater than 6. 10 is greater than 6. Yep. So this works. This is a good function. What do you think? Okay, so it's a little, this may be 35 minutes if I did this correctly, but I'm glad I got to fit these examples in that I don't have to do a separate video, but this is pretty cool. We went from an absolute value, a V-shaped graph, to 2 lines. And those 2 lines where the shadings are tell me what solutions work for that guy. So if you ever get stuck, go back to the definition of what an absolute value is and then see what the solutions can be. Okay, that can really help you out. All right, that's it. That is all I have for you. So hope you're doing well. If you have any questions, please ask. But until next time, guys, I will see you in the next lesson. Have a good day.